Welcome back to Math Mini Lessons. My name is Sarah, and in this video, we're going to go over the 5th grade state test. This is a two-part video. In this one, we're going to look at the multiple choice, and in the second one, we'll look at the constructed response. And huge shout out to Duke Ellington PS4 in Manhattan. All right, so let me tell you a little bit about the test itself. At this point now, if you're in New York, you're all taking the 5th grade test on computers. So I will actually do the multiple choice on paper because you have scrap paper and you're just choosing an answer. But for the constructed response, we're going to do those on the equation editor, and we'll do it as is, so you'll get to see me kind of struggle with some of it, but that's okay. For day 1, there are 30 multiple choice questions, and on day 2, there are 5 more. In this video, I'm going to do all 35 multiple choice, so I'm going to separate it that way, so you can see what it really looks like and sounds like. And what I encourage you to do, you can use the link on the bottom to get your own version of the test, or email me for a version so you can practice as well. And if you're in one of the schools that uses Math Mini Lessons, then you probably already have a copy of this test and you can give it to kids to practice and make corrections or to do some more studying. Okay, now day 2 has all constructed response as well. So altogether, multiple choice, there are, 30 points on day 1 because every multiple choice is 1 point. And then 5 points for multiple choice day 2, plus here's the breakdown of all the constructed response questions. So altogether there are 21 points. So this whole test is worth 51 points. And I'll give you a breakdown, so after you take this practice test, you'll be able to add up your points to see if you took that test today, what would your score be? And you can find out if you're a 1, 2, a 3, or a 4. So with that, let's get ready to jump into number 1. Here are the first 2 multiple choice problems, and what I do always, I'll give you the answers first. So if you have the right answers, awesome sauce. You can check off, give yourself a point for each, and move on to the next chapter. But if you don't have the right answer, and that's okay, this is what this practice is for. You can leave comments on the video. I've opened it up for this video if you want to see, if you want some extra practice problems or you want me to go into a strategy. But I'll show you some strategies that work for me. Obviously, I won't give you all the strategies because this video will be way too long. But I'll give you some ways to think about it, and feel free to share other strategies in the bottom. So stay on. If you don't have the right answer, just stay and watch how I do it and see if it makes sense. And we can even get some more questions for you later if that helps. But here we go. Here's the first 2. So here's the reveal. The answer for number 1 is D, and number 2 is C. So check off and see if you had the same ones. If you do, move to the next chapter. If not, you can stay here and I'll walk through the problem with you. All right, so for number 1, Carlos walks 3 6/65 kilometers on Saturday and 1 46 kilometers Sunday. What is the total number of kilometers he walks? So obviously we know we're adding, right? So if I was using some type of bar model, I know I'm adding 3 6/65 and 1 4600, and I'm finding out this whole piece. So how I'm going to add this together, I like to stack. And the key is you want to really stack up those decimals so that they're right on top of each other while you add. And that way you don't have any place value issues, because some of the numbers aren't going to line up completely the way this one does. And you don't want to make silly errors like that. But first problem, this one's super good to get. It's a nice easy win. So 5 plus 6, 11. 6 plus 4 is 10, plus 1 is 11, and 1 plus 5 plus 1 is 5. Now don't forget that you're going to put that last decimal. So notice all of my decimals go down in a row. That's what you want to see, them stacked up together. So that's how we get 5 and 11 hundredths. For number 2, we want to know which is equivalent to 5 times 3/4. And we did a lot of multiplying with fractions in 4th grade. So I'm going to do 5 times 3/4. And I'm going to put a 1 underneath the 5 to turn it to a fraction. And now I can multiply. I'm going to multiply my numerators. 5 times 3 is 15, and 1 times 4 is 4. So I want to know which of these will give me the same answer. All right. So looking at the first one is already a problem because I'm just adding them together. So that's an issue. That's not going to give me the same answer. As a matter of fact, If I was just adding 5 plus 3/4, I would just get 5 and 3/4. So no. And the second one, I'm just subtracting 5 minus 3/4. I'm going to have to do some regrouping. But I'm going to get 4 and 5 out of 5. Oops, sorry, I don't want 5 out of 5. I want 4 out of 4. So I can subtract. And I'm going to end up with 4 and 1/4. So again, not what I want. And because I have multiplication, I know I'm going to get some repeated addition. So let's think about it this way. 5 times 3/4 just means that I have 5 groups of 3/4. And that's kind of what I have here, right? I have 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. And when I add them all up together, I have 15/4, which is the same. So these have the same value. And on the bottom, I know that can't be the answer because I would have to multiply 4 times 4 times 4 times 4 times 4. That's a lot. Like 4 times 4 is already 16. Times 4 is 64. Times 4 again. So, whoa, this number is getting super big really fast. So there's no way that's the answer. All right, hit pause and make these corrections on your paper. And we'll move on to the next problem. Let's do the reveal for 3 and 4. So for volume, you'll get, it's a volume problem, I can see it, it's D. And for number 4, it's a rounding problem, also D. All right, so check off and stay here if you want to watch how I work through it. So the first one, we have a prism. And the reason I kind of knew that it was going to be a volume problem is because I had 3 dimensions. So it was a 3D image. So that means I have 3 dimensions here, a length, a width, and a height. So that makes me think of volume. I used to see a kid I went to see a movie in 3D, and I remember a kid saying, I wish all life was in 3D. And it's in 3 dimensions. So as soon as I thought of that, I thought this had to be a volume problem. And they're asking, which one will give us the total number of cubes? And volume can help us find that because the volume is telling us about space. Like this is a unit of space. That one block is a unit of space. And I want to know how many blocks I would have. So I know that I can find that with volume. Area would be for a 2D, something that was flat. And that would give me the space inside. So I would only have like a length and a width. No height. Height is just a dimension. And perimeter would just be the distance all the way around. Like if I walked all the way around something. But here, if I'm talking about the total number of cubes, how much space that is, that's volume. For number 4, I want to know what is this number, 34 and 275 thousandths, rounded to the nearest hundredth. So I'm going to write down my number. I'm going to find the number in the hundredths place. So, like I know these are ones, tens. I'm going to put these here so you can see it. Hundredths. I don't like the way I drew that. Let's do it again. When I want to know the place value of a number, because I need to know where the hundredths place is. So I know that I have tens, ones, and then they're all getting smaller by a value of 10. So I have tenths, hundredths, thousandths. And here's my decimal right here. So here's my number, 34 and 275 thousandths. Because it goes to the thousandths place. Should have made that 1 out of 1,000. Okay, so here's the number that's in the hundredths place. It's a 7. I'm going to look at its buddy to the right. So you're going to always look to the right side. You're going to look at that number. And you're going to ask yourself, is my number, if it's 0 to 4, I know I'm going to round down to the floor. If it's more than 5, I get to round up to the next number. So 0 to 4, round down to the floor. More than 5, round it up to the sky. So because this is a 5, I'm going to round up. So this number rounded up becomes 34 and 28 hundredths. Okay? So one thing that's where I got this answer right here. So what if that number was a 4? Does that mean that my 7 becomes a 6? No, 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 no. So just so you know, like when we round down, that digit just stays the same and everything else behind it becomes 0. Why? Because this number is between 34 and 28 hundredths and 34 and 27 hundredths. It's between these two. It's somewhere in here. If I go down to 26, that's all the way over here. It's further away. I'm passing 27, so I know that can't be the nearest hundredth. So please don't make that mistake. I have a lot of kids that think, well, if I round up, this digit goes up another number. If I round down, it has to go down another number, but that's a common mistake. All right, hit pause and jot this down into your notes. Let's look at the answers for 5 and 6, A and C. So check off, go to the next chapter if you have these. If not, stay right here. For number 5, the question is, we have the value of the digit in the hundredths place. In the number 653,841 is 1/10 the value of the digit in the thousands place of what number? So this is another place value problem. So let's think about, we're going to break this down. So here's my number, 653,841. And they want the number in the hundreds place. Okay, that's 8. So now it's telling me that this 8 is 1/10 the value of what number? So 800, it's not just 8, is 1/10 of what? Of what number? That's what they're really asking me. So let's think about this. 800 is 1/10 of a number. That means it's like 10 times smaller than what? That's what it's really asking me. So 800 is 10 times smaller than, I know how to do that. If I just move it to the next number, it's 8,000. Okay, so do you see what I did there? All I knew is that I multiplied it by 10 to figure it out. 800 is 10 times smaller than 8,000. So now I just have to figure out which of these has an 8 in the thousands place. And I just look at the 8s. And I know that it can't be, it's not letting me highlight that part. That's okay. Do that. I know it can't be D. And I know it can't be 10,000. This is 80,000. This 8 is in the 80,000s here. And this 8 is 80. And this 8 is 800. But this is the only one that has the 8 in the 8,000s. So place value problem, which we've been doing for a long time in school. But tricky the way they asked it, because now they're asking for a magnitude. It's 10 times smaller or bigger than. So they want to know if you know how to make numbers 10 times smaller or bigger. Or change any number by a magnitude of 10s. What if if it was 100 times smaller, then I would multiply it by 100. All right, so now you know that one. I hope that makes sense. Let's move to number 6. And we have a diagram in a box. So automatically, I'm seeing 3 dimensions. I'm thinking of volume again. And we have some cubes in the box already. How many more cubes are needed to fill the box? Okay, so I could already see that on the bottom, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or, let's just count it. I have 8 groups of 3. So my base has 8 groups of 3, or 24 cubic inches. What would the entire thing be? So for volume, I need all 3. I have 8 times 5 times 3. Or in other words, I'd have 8 times 3, and then I stack it up 5 times. So 8 times 3 times 5. So that's 24 times 5. Let's see, let's do I kind of want to stack it and I kind of want to do partial at the same time. I'm going to stack it. 5 times 4 is 20. 5 times 2 is 10. Plus 2 is 12. Okay, so in all, there are 120. If I would fill the whole thing up, but I already have 24. So how many more do I need? I need 96. Where am I getting that? I'm just going to subtract. This is 12. I can do 12 minus 2. But I can't do 0 minus 4, so I'm going to borrow again. I like to go from left to right and just ask, do I have enough? So 1 minus 0, I had enough. 2 minus 2, I had enough, but I didn't have enough for this here. So I had to do a lot of borrowing. Okay. So now that I have enough, 10 minus 4 is 6. And 11 minus 2 is 9, 96. Okay, and that's what's tricky about it. And I'm going to give you a secret. The first time I did this, I got the answer wrong and I put 120. Because I found the total volume and I forgot to read the second part that said how many more are needed to fill the box. So again, you could know how to do something, but if we're not reading carefully, we might miss some things and not really ask what's being asked. All right, hit pause and jot these two down into your notes. Let's look at 7 and 8. So the answers for 7 and 8 are D and B. Check off and see how you did on these two on 7 and 8. Keep moving if you have them. Stay right here if you didn't. For number 7, we have a group of 4 gold miners found 10 ounces of gold and they share it equally. How much gold did each miner receive? So I know I'm sharing the 10. So here's my 10 that's being shared. So I know this is division 10 divided by 4. Or I can think of it as 10 over 4. Either way, doesn't really matter. I can express it. But I need to actually solve this now, right? I need to do the division. So here's what's super cool about writing it down as a fraction. So I'm going to do that for a second. Is I can see it as 10 over 4 and then figure out in my head this is an improper fraction. So if I have 10 and I'm dividing it by 4, so here's one group of 4, here's another group of 4, I have 2 and 2/4, which I can simplify to 2 1/2. That's one way. The other way is to say I have 10 divided by 4 and just do 10 divided by 4. So this is just an algorithm way. Same thing as the drawing. 4 goes into 10 2 times. And I have remainder 2/4, which again I simplify to 1/2. And so either of those ways will work. So you can see that, notice here that they did have a 4 over 10, where some kids will just see these two numbers and might just pick that because their eye kind of sees it. So just be careful about those things and actually do the math before you pick an answer, instead of just trying to find something that looks like it, because our brains are going to say this looks the same and just pick it. Let's move to the next one. On Saturday, Mark sold 2 7/8 gallons of lemonade. On the same day, Reagan sold 2/3 as much lemonade as Mark. How much lemonade in gallons did she sell? Okay, so Reagan sold 2/3 as much as Mark. So Reagan sold, I want to know what is 2/3 of 2 7/8. That's a multiplication problem when I want to find that part. So I'm going to do 2/3 times, I have to change that 2 7/8. I'm going to have to move it. So 2 times 8 is 16. 16 plus 7 is 23. It's not my favorite problem, to be honest. Not my fave, but it's okay. But now I can multiply. For people who didn't know, all I did was say if I know 8 makes one whole, if I have 2 wholes, then I know 2 times 8 is 16 pieces. And then I just added the extra that was in there to get 23. That's all I did. All right, so I can multiply, and I get 46 over 24. So far it looks nothing like any of my choices, but I do notice it is an improper fraction. So I'm going to ask myself, how many 24s can I take out of 46? So let's just think about this. I know that 24 times 2 is 48, so I can only take 1 out. And that's going to leave me with 22. So I have 1 and 22 out of 24. So automatically I can get rid of these two. Boom. Okay, so far so good. I have 2 choices here. I don't see it because I do have to simplify now. All right, and I can figure out what's another common factor. Like, how can I divide 22 and 24? Well, they both have 2 as a factor. So I could just do, I'm going to divide it by 2 over 2, and I get 11 twelfths. So my answer is 1 and 11 twelfths. So some people probably would have just guessed and said 22 out of 24 is much closer to 11 twelfths. And I can see people doing that. But I also wanted you to see how I'm simplifying. And when I do that, all I'm doing is trying to think, I know I can multiply to make my fractions bigger, or my denominators bigger and still equivalent. So another way to make them smaller, or have a smaller denominator but still be equivalent, is to divide by a common factor, which is what I did. All right, so let's hit pause and jot this down into your notes. Let's look at 9 and 10. So 9, we could already see a 3D shape, so volume, C. And for 10, D. Check off. Stay here if you need to. So for the first one, we want to know what is the volume of this figure. Now this figure is not, I had drawn a little piece there, it is not a regular rectangle or prism. And we know that to find a prism, we need length times width times height. So what I'm going to do here is I'm going to split it, like break it down into 2 pieces, so that I can just chop this little piece off on the top. All right, we're chopping it off so that I have 2 pieces now, A and B, and I'm going to find the total volume of both of them. For the first part, A, what dimensions do I have? I have 3 by, this part here is 2. How do I know this is 2? Because down here this is 2. And they're the same. So 3 times 2. And now I need to know what this part is right here. So I know from here to here is 12. And I know from here to, let me put this one. Here to here is 12. And I know from here to here is 8. Because this is 8. So from here to here is 8. So this part up here has to be 4. All right, so I know that to find the volume of A, I'm going to do 3 times 2 times 4. So that's 6 times 4 is 24. So the volume is 24 inches cubed. My volume for B, this one should be a little easier. I have 10 by 8 by 2. So again, I'm using 8 from here to here instead of using 12. I only want this piece. I chopped off the top part. So 8 times 10 times 2. So 8 times 10 is 80. 80 times 2 is 160. And now I just have to add them together. 24 plus 160 is 184 inches cubed. Ba-bam! That's how I got the answer for this one. So it's definitely a decomposition piece. Let's look at number 10. Stephen has 3 cups of raisins. He shares as soon as I hear shares, I'm thinking division. He shares equally with himself and his friends. If each person gets 1/4 of a cup, how many people in total get raisins? So I know I'm doing 3 and I'm sharing equal share. So divide it by 1/4. All right, so first I'm going to change this into a fraction. And I'm going to rewrite this. We have some lessons on this. I'm going to rewrite this as a multiplication problem. So it becomes 3/1 times 4/1. which gives me 12 out of 1, or 12. Okay, now, if this does not make sense to you, and sometimes it doesn't, that's okay. What you could also think about is, if you had 3, and you can break it into fourths, and you can see that for the first cup 4 people can get, and the second cup another 4 people get, and the third cup another 4 people can get. So you can see all 12. So this is another way of dividing a whole number by a fraction. I could do it in a really concrete with pictures, or I can just rewrite my division problem as multiplication. But when you do that, please remember that this second fraction gets flipped over. Okay, hit pause and jot this down into your notes. And if you need to see that video to understand how to do this, please look at our 5th grade videos. Okay, we're doing pretty well here. Let's go to the next 2. And I see volume again because I see a 3-dimensional shape. So 11 is D and 12 is B. All right, let's go over them. For the first one, it's what is the volume of the gift box. So I'm going to start by writing, because I like my work to be super organized. Volume is equal to length times width times height. So now I'm just going to substitute the length, 9 times 5 times 10. 9 times 5 is 45 times 10. My volume is 450 D. Let's look at number 12. Sal, or Saul, it's Saul. I think that's how we say it. I like to say the Spanish version, but Sal is, I guess we're doing English. He has $6 in quarters and uses all his quarters to play video games. If each game uses 3 quarters, what is the total number of games? Okay, so we know that we're dividing our $6 into 3 quarters. So I want to know, let's see, how many quarters each game uses 3 quarters. So how do I represent the 3 quarters? Because I can't just do divided by 3. That doesn't make sense. $6 divided by 3. But I'm going to say 3 quarters. So I'm going to represent 3 quarters as 3 fourths. Okay, why? Because I know 4 quarters make $1. So 3 fourths. And now I'm going to rewrite this as 6 over 1. And I'm going to rewrite it as a multiplication times, and I flip the other one around, 4/3. And now I get 24 out of 3. And that's an improper fraction. I'm going to change this to a mixed number. So how many 3's go into 24? Well, 8. So you can play 8 games. If you're like, wait a minute, hold up. How does this make sense? Can I prove it? Again, here's the 6. Let's make $6. Let's break $6 into quarters. When we do this, you can see each dollar broken up. I can see the 24. So I have 12, 16, 20. That's the 24. That's my $24. I'm sorry, my 24 quarters. And now all I'm doing is figuring out how many groups of 3. So here's one group of 3. I'm going to change the colors. Here's another group of 3. That's another game he could play. Here's another game he could play. So far 3 games. 4 games. 5 games. 6 games. 7 games. He can play 8 games, because out of those 24, I have 8 groups of 3. So we can see it in there. So of those 24 quarters, when he splits it up, 8 groups of 3. All right, so again, drawing it can be really confusing, but I think for some kids it helps it make sense. Or you can just use the algorithm. I can just rewrite it as a multiplication sentence, which we know how to do. All right, hit pause and jot this down into your notes. All right, we have 13 and 14. So for 13, the answer is A. We're definitely going over that one. And for 14, the answer is C. All right, for 13, we want to know which statement is equal to, whoops, I want to use a lighter color, the quotient of 425 and 378 thousandths divided by 10 to the third power is true. So let's think about this for a second. What does that even mean, yo? All right, so I have 425.378, and I'm dividing it by 100. Oh, no, 1,000. So by 10, because if I had 10 to the first, that would just be 10. 10 to the second would be 100. 10 to the third, 1,000. So it's 1,000 times smaller. So I want a magnitude of 1,000. So what I'm going to do is I'm going to move that decimal I'm going to move it. So if I do this, this is 10 times smaller. If I move the decimal one time to the left. If I move it again, that's 100, another 10. So far it's 100. And move it one more time over here, that's 1,000. Okay? So 0.425378. Every time I move that decimal, it gets 10 times bigger or 10 times smaller. Every time. So if I move it to the left, it's getting smaller. If I'm just going to put a minus sign. If I move it to the right, it gets bigger, just like in a number line. My numbers to the right get bigger. If I go to the left, they get smaller. So now I got to figure out which of these things is true. So I'm going to read each statement carefully. So for number one, it says the decimal point is to the left of 4. So is that true? Yeah, here's 4. And it's true. The decimal point is right to its left. So that is the correct answer. All the other ones assume, like with the second one is to the right of 8. That's if you have moved the decimal point in the wrong direction, you would have gotten B. Okay, or if you had counted in any other way. So A is the correct answer. Let's look at 14. Carlos makes 1 pound of snack mix using nuts, raisins, and cereal. That's how many pounds of nuts and raisins he uses. He uses a third pounds of nuts and 2/5 pounds of raisins. How much cereal in pounds does he use? Okay, so that means I'm going to add all these parts together, right? So I have 1/3 plus 2/5 plus some number is going to give me 1 whole. So the first thing I'm going to want to do here is I want to just figure out like how much parts do I already have. And for this, I need these two. I can't add these two together until I make them the same denominator. So I'm going to do that. And the common denominator, just by seeing a 3 and a 5, I'm going to know the common denominator is 15. Okay? So in my head, what I'm doing is I'm just multiplying. Hey, I just want to get a quick denominator to make them the same. So I'm going to just multiply these together to get 15. All right, so first to get this 3 into a 15, think. I know that 3 times 5 makes 15, so I'm going to do the same thing to my numerator. 5 times 1 is 5. And I know that, again, 3 times 5 makes 15, so 2 times 3 will give me 6. Now I can add these two fractions, and that gives me 11 out of 15. So now I got to think for a minute. 11 out of 15 plus what? Is going to give me 15 out of 15. I'm just going to make all of them the same. Plus something is going to give me 15 out of 15. Okay? And this is something that we can figure out. 11 plus what makes 15? Obviously, it's going to be 4. 11 plus 4 makes 15. Okay? And the reason I didn't worry about the denominators is because I had them all the same as 15. So that's how I get 4 out of 15. All right, hit pause and jot this down. The key to this one was I need to be able to add two fractions with different denominators. And you can see how I used my my number sense to do that, I just use the opposite to do some mental math. But please do not worry if it seems like I'm doing a lot of this really fast and it takes you longer. That's very normal. I've just been doing this a lot longer, so it may feel faster. And also it's because I don't want the video to be too long, because I want you to stay focused and being able to watch it in 1 or 2 sittings. So don't get discouraged if it takes you longer to do some of this math that I'm doing quickly in my head. It's not a comparison. Everyone's running their own race. Hit pause and jot this down into your notes. We are almost at the halfway point of the first day, because I remember there are 30 multiple choice the first day, but we're going to go to 35. So here are the answers for 15, 16, and 17. B, C, and D. So check off with your notes, and I'm going to go through them one by one. With the first one, the company has an annual picnic. The company rents buses to transport the employees to the picnic area. There are 1,320 employees. Each bus carries 54 employees. This is the division problem. What is the minimum number of buses that the company needs? So it's going to be one of those, do I have enough? What happens with the remainder? So I'm going to divide by 54. And I'm going to do one number at a time. So I know that 51 can't be divided by 54. Neither can 13. So how many 54s can I take from 32? So I'm just going to count by 54s on the side. 1 times 54 is 54. 54 plus 54 is 108. So that's pretty close. And then if I add another 54, let's see, 4 plus 4 is 12. That would be 162. That's too many. That's too many. So I only can do 2. So luckily I know that 2 times 54 is 108 because I did it on the side. I can subtract. And I get 24. All right, let's bring down that 0. And now I have to count again. How many 54s can I get out of 240? Okay, so far I know I can do 3. Can I fit another one? So I'm going to try and add another 54 to that. 4 plus 2 is 6. 5 plus 1 is 11. Plus 1, that's 216. So I can do 4 so far. Can I fit another one? I don't think so, because I'm going to have more than 240. If I add 50 to 200 tonight, I'm going to have more. So that's 4 groups. And I'm going to subtract 216 and spiral. And I get 24 as a remainder. Okay, so I can have 24 buses, but what about those last 24 people? So I'm going to need a whole other bus. So the smallest number of buses I need is 25. All right. For this next one, what I can do is we're going to do some comparison. And because they have decimals, I like to stack things up so I can compare them. So let's look at the first one. And we can stack them together. And now I can see which one is bigger. It is 1400s is bigger than 400s. That's not what they wrote down here, so that's wrong. So that was A. 0.83 or 8300s, 0.92. Now it's easy to see this one's the bigger one. Again, that's not the symbol they used. They said that 8300s was bigger. Do you see how this stacking really helps me? Because instead of just reading it from left to right, I can just stack them and see which one is bigger. And boom, that one matches their thinking. Okay, so we can jot this one down into our notes as well. And I like these simple strategies for being able to compare. It just makes it easier for me to see it. All right, let's do this last one. Which value of K would make the product K divided by 3 times 12 greater than 12? Ooh, so okay, let's think about this. So I know that for when I multiply a number times 1, it stays the same. So if K is 3, if this is 3 over 3, it stays the same. That's the same thing as 1 times 12. Okay? So I need, for a number to be greater, I have to multiply by a number bigger than 1. So K has to be bigger than 3. That's the only way I can get a bigger number. So that matches D. Any value of k that is greater than 3. All right, so again, because if it's exactly 3, 3 over 3 times 12, I'm just going to get, that's the same as multiplying 1 times 12. If it's smaller than 3, like 2 over 3 times 12, my number is going to get smaller. But if it's bigger than 3, like 4 over 3 times 12, I'm going to get a number bigger than 12. And you can test all 3 of these out on your own to see if it's true. All right, hit pause and jot this down into your notes. All right, let's look at 18, 19, and 20. The answers are D, B, and C. Check off, and we'll start going over it. Let me make this a little bit bigger so I have space. For 18, we have the State Fair held the heaviest pumpkin contest. The winning pumpkin weighed 2,050 pounds. What is the weight in ounces of the winning pumpkin? So this is converting pounds to ounces, so you have to go back and look at the conversion chart. And since we have 2,050 pounds and each pound is 16 ounces, I'm going to multiply 2,050 times 16. So I'm going to choose to do some, why don't we do lattice for this one? Usually I just do traditional, but let's do a lattice. There we go. And I'll fill in the numbers inside in a different color. All right, so the first one is pretty easy. 2,050 times 1 is just 2,050. So that doesn't change. 6 times 0 is 0. 5 times 6 is 30. 6 times 0 is 0. 2 times 6 is 12. And now I can just add, and I get 0, 0, 8, 2, and 3. 32,800, which is D. I actually like lattice a lot. Traditional also would have worked, but I know some kids are using different methods, so I want to be able to show those as well. Let's look at 19. Which statement about the relationship between parallelograms and rectangles is true? Ooh, okay. So what do we already know about parallelograms and rectangles? So we know parallelograms just mean they have two sets of parallel lines that will never touch. And we know that rectangles have 4 right angles. And we know they're also parallelograms because they have 2 sets of parallel lines. All right, so I'm going to read each of these and then try to say true or false. All parallelograms are rectangles. Well, I know that is not true. That's false, because I can think of parallelograms that look like this, and that's not a rectangle because it doesn't have right angles. All rectangles are parallelograms, so that's true because they have 2 sets of parallel lines. But not all parallelograms are rectangles. That is also true. So B is correct. Let's look at C and D and figure out why they're wrong. All rectangles are parallelograms. That is true. And all parallelograms are rectangles. So that is false because we can think of parallelograms that are not rectangles. And lastly, not all parallelograms are rectangles. That is true. Not all rectangles are parallelograms. That is false because rectangles always have 2 sets of parallel lines. Okay, so a little bit of logic that to go in there, but notice how there are 2 statements in there, and both statements need to be true in order for the whole sentence to be true. All right, which value makes a comparison true? Some number is less than 6/10. So one thing I noticed is that some of these numbers are going to the tenths and some go to the hundreds. So let's make them all go to the hundreds. Let's make it easy. Okay, so now I can compare them, and I want to know which one is smaller than 60 hundredths or 6/10. Okay, so A is exactly the same. They're equal, so I can cross out A. It's not going to be smaller. B, 70 hundredths is more than 60 hundredths, so no. C, 59 hundredths is less than 60 hundredths. And here was D, 64 hundredths is definitely more than 60 hundredths. So I like stacking because, and notice how I use my placeholders, because now it makes it easier for me to compare when everything looks the same and goes to the same place value. All right, here are your 3 answers for this page. Hit pause and jot them down into your notes. All right, next chapter we have 21, 22, and 23. And the answers are C, D, and B. Check them off in your work. And if you have all 3, go to the next chapter, fast forward. If not, stay right here. Let's make it a little bit bigger. For the first one, Miss Smith has 1,104 photos to display around the school. He plans to put them on 48 poster boards. So automatically I'm thinking division, because I'm taking the photos and I'm putting them on boards with the same number of photos on each board. So yep, equal share, division. So how many would be on each board? So my number sentence is 1,104 is being divided by 48 will give me that number I want. So this is just division with a 2-digit number. Give myself some space. And I'm also gonna just do a little bit of skip counting on the side by 48. I know the next one would be 96. And 96 plus 20 plus 48 give me what? 96, 144. Okay, so I just wanted to give myself a little bit of a head start when I'm going in. All right, so 2-digit divisor, 48. 1 can't be divided by 48. 11 can't be divided by 48. How many 48s can come out of 110? 1, 2. 2 of them, because if I get 3, I need 144. That's too many. So here's 96. And I have a 4 and a 1. So I have 14. Bring down the 4. 48 goes into 44. Ooh, how lucky. 3 times. And notice how because I skip count on the side, I don't have to do the multiplying so much because I can literally count it on the side. So there we go, 23. So I can fit 23 pictures on every single board. All right, the next one, we kind of done one like this before. How many 1/3 are in 4 cups? So we did this. This was division. And we know that we're going to rewrite that as multiplication. And get 12. So that's very similar to something we've done before. And let's go to the next one. 3 boxes are shipped on a truck. Each box has a base of 16 square feet. 2 of the boxes have a height of 3 feet. 1 has a height of 5. What is the total volume? All right, so I know the bases, and that's super helpful. So for the first one, I know my base. Well, for all of these, I know what my base is going to be. My base is 16. It's just the heights that are different. Okay, so big B is 16. But my height, and this one is going to be 5. So for volume, I'm going to do my base, my big base, times my height. 16 times 5 is 80. For the other ones, I have B is 16 and B is 16, but my heights for these are 3. So volume equals base times height, or 16 times 3, which is 48. So, and I know the same thing is going to happen here. All right, so now I just have to add all of those up together. 48 plus 48 plus 80. I don't want to do that in my head. 48 plus 48 plus 80. 8 plus 8 is 16. 8 plus 8 is 8 plus 8 is 16 plus 1 is 176, or B. So here, the part that's tricky is instead of giving you the length, you might be going, but I don't know what the length and the width are. You don't need them because they already multiplied them to give you those bases. That's what's happening here. They've already multiplied the length and the width to give you the base of 16. And now I just had to multiply by the height. All right, hit pause and jot this down into your notes. All right, here are our next three. The answers are C for 24, C for 25, and D for 26. Check them off. And let's start with the first one. What fraction has the same value as 28 hundredths? So you can kind of hear it when I'm saying it. And how do I know it's 28 hundredths? Because I know my place value. So I know these are ones, tenths, hundredths. So I can say the same 28 hundredths means I have 28 over 100. And here they just didn't simplify it. They kept it as is. So you can use its name, or you can just use your place value chart to help you figure out what the fractional form is. Let's look at the next one. What is 680 and 14 thousandths in standard form? So I love this because I have a first name and a last name. So the first name, 680, tells me how many whole numbers I have, 680. The and tells me now I'm going into the fractional part. So I need the 14 to go to the thousandths place. Okay, so that means my last number has to go tenths, hundredths, thousandths, 3 digits to the end. So that means my 14 has to come all the way to here and a 0 in front. All right, so that's how, it's kind of like a first name, 680, and this is 14 thousandths. So how do I know that it wasn't this? Well, because I would read this as 140 thousandths. Or how do I know it wasn't this? Because I would read this number as 104 thousandths. So that's how I know that this number 14 had to go to the end. All right, so let's jot this one down. That also matched C. And the next one is adding fractions with different denominators. They have different magnitudes of 10. What is the value of 3 tenths and 27 hundredths? So 2 ways you can do this. One is you can make a chart. And here's my tenths. And here's my hundredths, right? And here's my ones. So if I have 3 tenths, I could just put 3 in the tenths place. Here's my decimal just so you can see it. 3 tenths. And then if I have 27 hundredths, then my 27 is going to go over here. It ends. That digit has to be there. Like I can't put 2 digits in here. 1 digit has to be in this place. And 1 digit in this place. And now I can add these up. Notice this needs a little placeholder. Boop. But I can add now. And I get 57 hundredths or 57 out of 100. How do I know? Because it's 57 out of 100. So that's one way you can solve this. I want to show you another way. So another way we can do this is I can make it so that I want like 3 tenths. If I want to make it the same denominator, like if I want to make it into hundredths to make it easy, just think for a minute, what would I have to multiply by? My denominator to get to 100. I'd have to multiply by 10. I do the same thing to my numerator. 10 times 3 is 30. So now that I have an equivalent fraction, I can add these up. And I would still get the same answer. Whoop! 57 over 100, which is D. Okay, so I like that I have just, again, different ways, different approaches for doing things, different strategies. And we can appreciate that there's more than one way to get to a place. And I hope you're seeing things that make sense to you. Hit pause and jot these down in your notes if you need to make any changes. All right, let's do 27 and 28. The answers are A and A. Awesome. So let's start with the first one. What is the value of the expression 1/7 divided by 5? All right, so one thing I could do is I can just rewrite this as multiplication. So instead of saying divided by 5 over 1, I can just do 1/7 times, and then you flip the second fraction. So you find this inverse, you would just change it around, we flip it, it's called a reciprocal, and I get 1/35. That's one way. If you wanted to, I guess if you wanted to see it visually, what would that look like? So this is not going to be the scale. Wow, that's an ugly rectangle. Let me try it again. Not perfect, but it's okay. So I have 1, 2, 3, 4, 5, 6, 7. So you can imagine that this is 1/7 over here. Okay? And now they're saying, like, if I were to divide it into 5 equal pieces. So 1, 2, 3, 4, and 5. So now look, now I have all the pieces. How many pieces do I have here? I have 5 groups of 7. That's how I know I have 35 pieces, 5 groups of 7. And I want to know, so that's that one little part. And I end up, I want to know, let's see, 1/7 divided by 5. Each of these little pieces is just 1 out of 35. So again, if I just took this little piece here, I've taken this 1/7 and I've broken it up into 5 little pieces. So now each of these little pieces is worth 1 out of 35. So I have my answer A. So again, you can see the algorithm, you can see it visually. Let's look at the next one now. Marcel has 2 1/3 cups of milk. He uses 2/3 of the milk for a cereal and 1/4 for a pancake recipe. How much milk does he have remaining? Okay, so this is my number sentence. So I know I have 2 1/3. I'm going to take away the 2/3. And I'm also going to have the other 1/4. So actually I'm going to add these two together. Okay, because that's the part he used. And I'm going to add those up together and subtract it from my total. That's going to be my goal. So let's start by figuring out how I'm going to add these two fractions that have different denominators. So I have 2/3. Let's change this to a fraction. So 1 1/4. So one piece will just be 4 out of 4. So this is 5/4. I want them to have the same denominator. So I'm going to, on this side, multiply by 4 over 4. And on this side, I'm going to multiply by 3 over 3. Okay, so that this fraction here is 8/12 plus 15/12. So all together in this part, 8 plus 15 is 23/12. Okay, now I still need to subtract on the other part. So I'm up to now 2 1/3 minus 23/12. Let's also change this other part over. 2 times 3 is 6 plus 1, that's 7/3. But that has, I need it to have the same denominator of 12s. So how do I get it, make it into 12s? Just going to multiply by 4 over 4. And that's going to give me 28/12. Now I can subtract 28/12 minus 23/12, and you get 5/12. So this was a lot. There was a lot happening in this problem between adding and subtracting mixed numbers, fractions of different denominators, multiple steps. But also this is happening at the end of the test when you're probably the most tired. So they're expecting that this is where kids are going to make more computational errors. So take your time. This is where taking your time can really be helpful. All right, hit pause and jot this down to your notes. And if you need help adding and subtracting fractions with unlike denominators, go and look at our 5th grade playlist. We have videos on this. These will be the last 2 questions for day 1. So for 29, you have C, and for 30, you have C. So let's start with the first one, 29. Anna is nailing a figure that has 3 columns of unit cubes. The first column is shown below. Okay, so I can see it. And when I counted it, I saw it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's just the first one. So now they're telling us about the other 2. The other 2 have 4 fewer cubes than the first. So, all right, 10 and 4 fewer just means minus 4. So the other 2 have 6 cubes. What is the volume in her figure? Well, the first one has a volume of 10 units. So 10 plus 6 plus 6. And that's going to give me 22. So what's tricky about this one is that I don't have like a prism. I don't have a 3D shape except for these 1 cubes, but I had to use what I knew about the other 2. And that is very easy to figure out if you just take a moment and just think, what does it mean to have 4 fewer than 10? And here's our last one. What is the area of a rectangle with lengths? Oh, God. 3 3/4 and 9 1/2. So a doozy at the end. Okay. So we're going to multiply because we know area is equal to length times width. And that means we're multiplying 3 3/4 times 9 1/2. So this one's definitely a doozy for an ending. We're going to start by let's change these to improper fractions first. So I know that, so I have fourths here. 4 times 3 is 12. 12 plus 3 is 15. So I have 15 over 4 times 9 times 2 is 18 plus 1 is 19. 19 halves. Well, at least the denominator is friendly, is 8. But those numerators, 15 times 19. Okay. Let's give ourselves some space. Do it one piece at a time. 9 times 5 is 45. 5 times 1 is 5. Plus 4 is 9. And 1 times 9 is 9. 1 times 1 is 1. So this would be 285. Okay? So here's what I have so far. Now, obviously, I have an improper fraction here. None of my answers are in improper fractions. So now I have to change this back to a mixed number. So we're going to use division. We're going to do 285 divided by 8. 1 digit at a time. 2 divided by 8 is 0. 28 divided by 8 is 3. 45 divided by 8 is 5. And so that gives me a remainder of 5 8s. And there you go. So yeah, this one, it was a doozy for an end of problem, an end of day 1. But there you go. We multiplied mixed numbers. We changed them into improper fractions. We multiplied carefully, and then we changed them back to mixed numbers. So I pause and jot this down into your notes. Now, we're going to keep doing the last 5 problems, which are from the next day, day 2. So it says as if you went home, you rested, now you're fully rested to start off the second session. So let's just jump right in. Okay, 31, 32, and 33, the first 3 problems of day 2. And the answers are C, C, and B. So stay here if you still need us to go over any of these. If not, go to the last 2 problems in this video. For the first one, Rita is walking on a trail that is 2.5 kilometers long. She has walked 72 hundredths kilometers. so far. How many more does she still need to walk to complete the trail? Okay, so I'm just subtracting. So 2 5/10. I'm going to line up my decimal to put 72 hundredths. To subtract, I'm going to put a placeholder here. Now I can subtract. I like to go from the left and just ask, do I have enough? I can do 2 minus 0, but I cannot do 5 minus 7. So I'm going to have to regroup. And now I have enough. 15 minus 7 I can do, but I cannot do 0 minus 2. So I'm going to regroup again. And now I have enough. 10 minus 2 is 8. 14 minus 7 is 7. And 1 minus 0 is 1. So I get 1 78 hundredths. Alright, so let's jot this down into your notes. The big key, honestly, is the placeholder. You're going to make a mistake. It's probably because you didn't put a 0 behind the 5. Next one. What is the value of this expression below? So all three of these have different denominators. So I'm going to give you a strategy for this. Because I need all of them to have a common denominator in order to do this. So I'm going to use a table method. And what I'm going to do is for each of these fractions, I'm just going to skip count until I find something they all have in common. I like to kind of start with the smallest ones first, usually, just so I know kind of what I'm working with. So I'm going to do 2, 4, 6, 8. So I see a possible for 3 and a possible for 4. 3, 6, 9, 12. And I'm going to count by 4s, 4, 8, 12, and 16. So far I see that we have a common one for 3 and 4. I have a common one for 2 and 3, but I don't have something that's in common for all of them. Here's 2 and 4. So I'm going to go and keep going a little bit more with my smallest fraction. 10. I see one. I see one. It's the 12. 12 is my common denominator. So now I'm going to skip count just to get that full fraction. So my first fraction is 6 twelfths, 2, 4, 6, 8 twelfths, 2, 4, whoops, go back, 1, 2, 3, 4, and I get 3 twelfths. Now that I have equivalent fractions, I can change this up. So 1/2 plus 2/3 minus 1/4. So 1/2 is 6 twelfths, 2/3 is 8 twelfths, and minus 1/4, which is 3 twelfths. This I can do. 6 plus 8 is 14. And 14 minus 3 is 11. So now I've simplified it all together. So I like the strategy a lot just because I have 3 different denominators. I know some kids probably would just multiply all 3 together, and this could work. You could just say, well, 2 times 3 times 4 makes 12. And you could have just done that. But I also wanted you to see the table why it works. All right, let's go with the next one, and it's a geometry one. Okay, that means we have some geometry words here. Needs to draw a 4-sided shape, so it's a quadrilateral, with 1 pair of parallel lines. So anytime I see 1 pair of parallel lines, I know that this is a trapezoid. All right, so that's important. And this trapezoid has 2 right angles. Okay, so what could it be? So I'm going to do one at a time. So for A, could it be a square? No, because it only has 1 pair of parallel lines. And a square has 2 pairs of parallel lines. Like when we draw it, these are parallel and these are parallel. So I can just eliminate A altogether, because as soon as one thing is not true, the rest are not true. B is a trapezoid, yes, because it has 1 pair of parallel lines. It's a quadrilateral. Yeah, because it has 4 sides. And it's a polygon. Yes, because it is a shape with it's actually a multi-sided shape. C cannot be true because it's not a rectangle, so I can just stop there, and it's not a parallelogram. And D, I could definitely say it's not a parallelogram. So I found one thing is not true, so I can close it. All right, let's hit pause and jot this down into your notes. Last 2 multiple choice in this video. For 34, we have D, and 35, we have C. So stay here if you need to go over. If not, I will see you in the next video. Elise has 2 equal-sized bags of rice. One bag is 1/3 full. The other bag is 1/5 full. If she combines the rice, so she's adding them together, what fraction of a full bag does she have? All right, so I know I'm adding 1/3 and 1/5. So fractions with different denominators. So I am going to actually want to show you this way of adding them together. So I know that I need a common denominator, so I can just multiply 5 and 3 and get 15. Now watch what I'm going to do here. I can do cross products to figure out my new numerators. So for the one on the left, 1 times 5 is 5. And on the right, 1 times 3 is 3. Now you may be going, what are you doing? Well, this is what I'm doing. So remember before, in other videos, I said you can just multiply by 1 to get the other number. So on this side, I can multiply by 3/3. And on this side, I can multiply by 5/5. That way, I know I'm going to get the same denominator, 15. That's what you're seeing here. Now look up here on my numerators, I'm doing 1 times 3, which is the same as doing here 1 times 3. And you're going to get 3/15. See? 3/15. And on the other side, I have 1 times 5, which I can also see here, 1 times 5. And that would give me 5/15. So that's how when I did this, I got 5/15. And I'm adding these two together, and I would get 8/15. If you did it the longer way, which is fine, it doesn't matter which way as long as it makes sense to you, you would also get 8/15. Okay, but I wanted to give you another algorithm, another way. Once you get really good at adding fractions with different denominators, some kids really prefer this method, but I want to show you where it is. It's the same math. It's just that this is more compacted, so it's kind of hard to see it. And it makes it look like a trick, which I don't particularly love because I don't want it to look like magic. It's real math. There's sense behind it. But sometimes when it looks too easy or so much of the math is hidden, it just looks like magic. And that makes it feel different for me. I want you to know that there's something behind it that you can't solve. All right, and here's our last one. We have the distance between 2 houses is 450 meters. What is that in kilometers? So in everywhere else in the world, they use the metric system. So we have meters. And what we know, I'm going to do this 2 ways again. We know that 1 meter, I know that 1,000 meters makes 1 kilometer. That's in your reference sheet. So if you have 450 meters, how many kilometers is that? Well, it's definitely less than 1 because it's smaller. So what I'm going to do is, I know that 1,000 to 1. I know 1,000 is 1,000 times, I have to go 1,000 times smaller. So this is what I'm going to do. I want it to be 1,000 times smaller. So here's 450. And I'm going to go, this is 10 times smaller, 100 times smaller. Here is 1,000 times smaller. So that would be 0.450 kilometers. which does match here. It just didn't have that little 0 in the back. Same thing. So that's one way you can do it. It takes a lot of logic. You do have in the reference sheet kilometers and meters. And if you know Spanish, then you know you can also, I think in a lot of Spanish countries, they also use a metric system, so you might know that. But I want to give you another way. Let's say I know my metric system, and I know I have meters, and then I have decameters, which means 10 in a meter, and then I have hectometers, which is 100, and then I have kilometers. And usually we only use kilometers and meters in this country. Okay, so I know that I have 450 meters. So I'm going to write this here because I have 450 meters. So what would that be in kilometers? Well, here I don't even have one. There's not even a full one here. But I can actually just put the decimal down and I can see that I have 0.45 meters. So this is just another way, another visual way using tables that can help me convert units. But you also can just know that a kilo, there are 1,000 meters in a kilometer. All right, well, that's it for multiple choice for today. Remember, each multiple choice is worth 1 point. So go back over and look to see how many multiple choice you had right, and that will tell you how many points you have from this one. In the next video, we're going to look at the constructive responses, and once we have those points, we'll figure out how you would have done if you would have taken the test today. I'll see you in the next one, Math Marbles. Thanks for working so hard on this. And again, if you have questions, put it in the chat. If you have new strategies, add them as well. We're here to help you, and we know that you can rock this 4th grade test. That's it for today. I'll see you next time, Math Marbles. Be well.